Hello students, welcome in chapter number 11, 3 dimension geometry. Students, today I continue related our plane derived by the intersection between two planes given and having passing through one of the points. So exercise 11.3 question 9, find the equation of plane through the intersection of plane 1 and plane 2 and passing through given 2 to 1. It means students, first of all I will take our drawing in this way. That's your plane 1 and similarly that's your plane 2, and between that common intersection between the line have here our third plane. We will derive that in the answer. That is a plane 1, it is plane 2, and that's my answer, plane 3, which passing through the points 2 to 1. My first plane is a 3x minus y plus 2z minus 4 is equal to 0, and second plane x plus y plus z minus 2 is equal to 0. First I check given point passing through A plane first or passing through B plane. So A point is, I will check only 2 to 1. Sometimes it's passing through, otherwise sometime not, but we will check necessary. 3 here 2, y is 2 and z is a 1, and check is equal to 0 coming or not. That is 6 minus 2 plus 2. Yes, they are not equal to 0. 6 minus 4, it is 2, never 0. It means plane first is not your answer. Now continue, I will check 2. Second plane which have to x plus y plus z minus 2 is equal to 0. So 2 plus 2 plus 1 minus 2 is equal to 0. This also 3, never 0. It means therefore we will say plane 1 and plane 2 is not our required plane. Yes, that's your saying that sometimes they are belonging answers, then is equal to 0, then you can write down it is your required plane 1 either required plane 2. Now it's both not a required plane, so now I go to lambda theory and derive my third plane. So students, now I assume that related plane 1 and plane 2, suppose required equation of plane first plane plus lambda, second plane is equal to 0, where lambda belongs to R. If these are belonging answers, so you not write down with equation 1 lambda. If your second answer is also your answer cover plane 2, then second place you don't write down the lambda. Here first plane I write down, both have not belonging, therefore my third plane is in that way. I just write down here plane 1 and plane 2. I again repeat, if you plane 2 is 3 is equal to 3 coming, either 0 equal to 0 coming, then you cannot write down lambda with the plane 2. You write down here lambda. Now this is your answer. It's passing through point A 2 to 1. That's your third plane passing through on it. So 3 with 2 with 2, 2 with 1 and minus 4 plus lambda, here also 2 2 1 minus 2. So your answer is very easy, this cancel, 3 to the 6 minus 4, and here 2 to cancel, 2 plus 1 3. It means your answer is 2 plus 3 lambda. So lambda become minus 2 by 3, and this lambda value I putting in this suggestions. So required plane, third plane, that's your answer to 3x minus y plus 2z minus 4 minus 2 by 3 x plus y plus z minus 2 is equal to 0. And just you take 3 upside, 2 right side. So 3 3 is a 9x, 3y, 3 to the 6z, and 4 is a 12, minus 2x minus 2y minus 2z plus 4. Now LCM I cancel with 3 into 0. So 9x, 3x, 7x minus 5y plus 4z plus 6z minus 2z, and last minus 12 plus 4 minus 8 is equal to 0. That's your final answer. Same students, I going ahead. Our question number continue in the 10th one. Similarly given, find the equation of plane which is passing through given 2, 1, 3. These are passing through only change 2, 1, 3. And the plane given, this plane are change. In the first plane r dot 2i plus 3j plus minus 3k is equal to 7, and second plane given is the same as to r dot 2i plus 5j plus 3k is equal to 9. One more time check, and this question number 10 our students. So find the equation of plane through the intersection of the planes are r dot 2i 2j, my mistakes, 2i here 2j, 2i 2j minus 3k is equal to 7, and second r dot 2i 5j and 3k is equal to 9, and passing through 2, 1, 3. It's very easy. Process is same, drawing also same, only these are plane change. Students, passing through point change and plane equation change, and I just go to first of all checking. So my passing through A 2, 1, 3, and just I check again 2, 1, 3, yes true, and plane 1 is a here plane 1, 2 into x, 2 into y, 3 into z, minus 7 is equal to 0. Convert in our form of the Cartesian. And second here 2x, 5y, 3z minus 9 is equal to 0. So I just checking first of all plane 1, 2, 1, 3. What's your plane 1? My plane 1 is 2x plus 2y minus 3z minus 7, and you just putting your 2, 1, 3 in place of x. Here 1, x is a 2, sorry, y is a 1, z is a 3. So your answer is a 4, 2, minus 9, minus 7. Here 4 and 2, 6. And here students 7 and 9, 16. It get minus 10, but never 0. Yes, it is 7, 9, 16 and the minus 10. It means plane 1 is not your plane 3. Yes, so that's not your answer. Second check 2, 1, 3. 2, 1, 3, I will go into second plane 2x plus 5y plus 3z minus 9, and here also I will check 2, y is 1, z is 3. So your answer is a 4, 5, 3 3 is a 9, and this cancel, and it will check it is equal to 9. So no, it means plane 1 and plane 2 is not our required plane. Sometimes they belong. Now I go to suggestion. Suppose required plane is a plane 1 and plane 2. I just mentioned in the lambda theory and easily derive our value of lambda. So suppose required equation of plane, here plane 1 plus lambda plane 2 is equal to 0, where lambda belongs to R, and simple apply the value. First your lambda is plane 2x plus 2y minus 3z minus 7, and similarly students you will cover to your second plane as similarly to next plane 2x plus 5y plus 3z minus 9. Now it's given that passing through 2, 1, 3, so it's passes through A 2, 1, 3. So I just apply in place of x2, y is 1, z is 3. So here 2 into 1, I mean x is 2, sorry. 2 into 1 y, z is 3 minus 7 plus lambda. Here also same, 2 into 2, y into 1, z into 3 minus 9, and just calculate. You will get here easily your value for lambda. So here 4, 2, minus 9 minus 7, and that will be 4. Next 5, 9 minus 9, please cancel. Already they calculate here, students, check. Here 4 plus 2, minus 9 minus 7, it is minus 10, because here 6 and minus 16, minus 10, lambda here 9. It is lambda become 10 by 9. Now that value lambda you put in the equation above, suggestions. So required third plane, which is passing through the intersection between plane 1 and plane 2. I just mentioned here 2x, 2y, 3z minus 7 plus 10 by 9, 2x, 5y, 3z minus 9 is equal to 0. Students, this 9 I multiply that, and 10 multiply these sides. So 9 into 2, 18x, 9 2s are 18y, 9 3s are 27z, 7 9s are 63, and here 20x plus 50y plus 30z, and 10 3s are 30z, and minus 90 is equal to 0. Now just arrange the like terms, 18x, 20x, so 20, 30, 38x, 18y, 50y, 50, 60, 68y, 27z plus 3z, plus 3z, and last of the 63 and 90. So it is 90 minus and minus 63, it is 3 and 53, yes, minus 153. So that's your required plane, 38x, 68y, 3z is equal to 153, and that's the students your answer to plane intersection with plane 1 in plane 2 common and having passing through 2, 1, 3. So your answer is given in the vector forming. Yes, in your textbook answer, students, 38i, 68j, 3k. So I also write down in the vector form, in vector form asking in the textbook question. So this also correct, 38i plus 68j plus 3j, I mean 3k, and is equal to students 153 with r dot. Here given that our r dot is equal to 153. So this also true, either that also true, both of the correct. Now question continues, students, 11th, which is most IMP for final exam. Question number 11. Most currently numericals are many time asking in the final exam. Question number 11. So you tick mark in the very most IMP, and one by one I explain, same as to question number 10. So students, I continue question number 11, which is IMP questions. Find the equation of plane passing through the line intersection of the planes plane 1 and plane 2. It means both plane 1 and plane 2 common intersection. I answer your plane 3, but it is perpendicular to that plane, x minus y plus z. So students, here explaining is same, but we utilizations the rule of perpendicular. It means both directions dot is equal to 0. And that principle we will use in these questions. Very easy. First of all, given planes, I just told plane 1 and plane 2, also plane 3. Three planes are given. First plane is a x plus y plus z, minus 1 is equal to 0, 2x plus 3y plus 4z minus 5 is equal to 0, and plane 3 is equal to 0. I just define that normal of the plane 1. Similarly, normal of the plane 2, and similarly normal of the plane 3. And in plane 1 normal is just coefficient that 1 1 1, second 2 3 4, and last 1 minus 1 1 1 minus 1 1. Our target is intersection between plane 1 and plane 2. Read properly. Intersection of the lines plane 1 and plane 2 and perpendicular to plane 3. So first of all, I just draw intersection of the plane 1 and plane 2. That's your plane 1, which is our equation is x plus y plus z minus 1 is equal to 0. That's the second plane, plane 2. The equation is 2x plus 3y plus 4z minus 5 is equal to 0. And between the common region, it means that's the plane number 4. Yes, that your answer to plane number 4 I will derive, which is perpendicular to plane 3. Plane 3 after that I draw, only I draw first of all up to that. Now I checking first plane 1 and plane 3 is perpendicular. Sometimes your answer is a perpendicular that. So for plane 1 and plane 3, so n1 dot n3 I will check, and if you then dot product is 0 coming, then plane 1 is your answer, is see plane 4 converting. Now here plane n1 is a 1 1 1 dot your 1 minus 1 1, and you check the answer 1 minus 1 plus 1, it is c1, but never 0. Same as I will check to for plane 2 and plane 3. Similarly checking to n1, n2 dot n3, and the value is n2 n3. What's your n2? Yes, 2 3 4 dot n3 1 minus 1 1. My answer is 2 minus 3 plus 4, 4 and 2 6 minus 3 3, then not 0. It means plane 1 and plane 2 is not perpendicular to plane 3. It means not your answer there. Therefore we can write down plane 1 and plane 3, I mean plane 2 is not our required plane. Now this required plane 4 I will take in the lambda theory. So suppose required plane 4th, which is common intersection between 1 and 2, yes, is first plus lambda, second plane is equal to 0, and lambda belongs to R. First is x plus y plus z minus 1, and second 2x plus 3y plus 4z minus 5. So does this plane is your answer, but lambda value is missing. But the plane 4 is perpendicular to plane 3. It means that's I just explaining here about to converting your up to normal first. After that I will make the drawing. So x plus y plus z, 2 lambda x, 3 lambda y, 4 lambda z minus 5 lambda. So does this x and this x you will take combine common. So 1 plus 2 lambda x. Same y and 3 lambda y, it is a 1 plus 3 lambda y common. And similarly z. So 1 z is your students here 4 lambda z. And constant I will write down minus 1 minus 5 lambda is equal to 0. Here this is your general form of the plane Lx plus my plus and z minus d is equal to 0. So the normal defined, yes. So normal of plane 4 is that n4 you easily write down LMD according to that 1 plus 2 lambda comma 1 plus 3 lambda comma 1 plus 4 lambda. Now read question again, students. Find the equation of plane passing through common intersection between plane and plane 1 2 means this and perpendicular to plane 3. So students, this is your drawing, that's your plane 4, that is perpendicular to your plane 3. That's your plane 4 having normal n4, and this is your plane, students, 3 having normal n3, and both between 90 degree, it means dot product of both normal is 0. So that's your n4 and n3 I will apply. This is your n4, that's your n3. What's your n3? Yes, 1 minus 1 1, and that's also ready. 1 plus 2 lambda, 1 plus 3 lambda, 1 plus 4 lambda, and that utilization is value of lambda, and that lambda put it here and you will get answer. So now I go to equations. Now plane 3 is perpendicular to plane 4, therefore n3 dot n4 0. And what's your n3, students? 1 minus 1 1 dot n4 1 plus 2 lambda comma 1 plus 3 lambda comma 1 plus 4 lambda is equal to 0, and you will apply simple in the way of our dot product and easily get your answer, value of lambda. Indirectly, this is a 4 marks question, students. Exam oriented IMP and 4 marks numerical. So I will get now dot product. So 1 with 1 plus lambda, 1 plus 2 lambda. Next minus 1, so minus 1 minus 3 lambda. And last 1 plus 4 lambda. Again repeat, 1 plus 2 lambda, minus 1 minus 3 lambda, and 1 plus 4 lambda. So finally, students, this one and this one gone. You have to 4 lambda plus 2, 6 lambda, 6 minus 3, 3 lambda plus 1. So lambda become minus 1 by 3. That's your value. And lambda put down here. So required plane, 4th plane. That's your answer to x plus y plus z minus 1, lambda putting 2x plus 3y 4z minus 5, and this 3 you will take multiply, and here multiply to 1. So your answer is 3x 3y 3z minus 3, and this side minus 2x minus 3y minus 4z plus 5. So does this 3y and 3y gone? You have to only x plus 0y minus z plus 2, and that's your equation of plane, and that's the students final answer. Just I will check the answer. X minus z plus 2 is equal to 0. Here only given Cartesian plane, not the given to our vector forming. And here students, our this questions ending with this part also, students, I stop here, and further explanations for this exercise, students, I will explain in the next part. Bye bye.